In this lesson, we're going to have a look at the filtration shutdown sequence. So we can have a look at an example of a cancelable shutdown sequence. Now, what I mean by that is the way this is set up means that the parent sequence, or the filter sequence manager's sequence in this case, the one that's controlling the filter, won't forget where it is, even though a shutdown has started, but then has subsequently been cancelled. So let's go in and have a look at this filtration shutdown sequence here. Just bear in mind on the interface that we have our normal shutdown, fault shutdown, the sequence step for the parent sequence, and the data sets that we have for the valves. And then also we have our outputs, which are the requests to shut down AVO1 and the request to shut down MVO2. Inside, the changes that I've made are quite simple. I've simply removed the latch for the shutdown required. So if we are in the idle step, it won't latch. And I don't think it did much anyway, if I'm honest, because we immediately move out of idle as soon as the shutdown is active anyway. So if the normal shutdown comes in, or the fault shutdown comes in, or fault request comes in, then this shutdown will be on and we'll move to close valves. We will immediately request that MVO2 closes, the outlet valve closes. This has a travel time because it's a modulating valve. And we don't allow AVO1 to start closing until MVO2 is closed. But in the meantime, as soon as we enter the closed valves, we also come down to this step and we move into validate valve positions. Now, this change here is what allows us to exit this, this shutdown sequence. So basically what I've done is I've got a normal shutdown request or fault shutdown request. Then we monitor the feedback of these valves. But if we end up in the position during the flight time of the valves that a normal shutdown request and a fault shutdown request are no longer active, then we move idle into the sequence, which takes us back to step 0. Now, if we look at our code for the filtration sequence, when we request a shutdown, saying the filtration is shutting down or shutting down due to fault, what happens here is at the beginning of every step that moves us on in the sequence, we do a check to make sure we're not shutting down. Or if we have a complete fill sequence, we shut the fill sequence down. But what we don't do is go back to idle. We don't force it back to idle. It is the job of the filtration shutdown sequence to move into the parent sequence, the shutdown, which means that whilst this sequence is active, the parent sequence, the filtration sequence, is just frozen. It's not allowed to move. It can't move on to the next step. And down in our filtration request handler, where we have the request coming in, this shutdown would be active here for MVO2, meaning MVO2 has no command to be open. So according to our management style of MVO2, we would begin to shut the valve or move it to the position it needs to be in. So the shutdown sequence is doing what it needs to do. It is shutting MVO2, but the parent sequence is still sending an open request because it's still in a step where we're sending that open request. Now, if something were to happen where MVO2's shutdown close request was removed, such as the filtration sequence shutdown sequence going back to idle, which will put us back up here, and remember both of these are off so it won't restart, then this close MVO2 request falls away. And when that is set back to false, the only thing that is true on this run is the open request. And this filtration sequence will no longer have this shutting down due to fault, or this one here shutting down due to fault. So it can then move on into the filtration active step, or wherever it got interrupted by the shutdown sequence. And understanding where you can jump in and make those changes to give you things like cancelable sequences, or sequences that don't interrupt or aren't part of the main sequence. If we had had what I would consider a traditional setup of the shutdown sequence using a value in this main sequence step, you then have to start grabbing historic values and setting set coils and things like that to keep pumps running or whatever it is you're doing whilst you move into another sequence using the same sequence step variable, which is something that I don't want to do. I want to have a dedicated shutdown that has nothing to do with the main sequence, but can update the main sequence back to its idle step, which turns everything off and shuts everything down, using this in-out variable here for the main sequence. And I do a controlled shutdown by offering shutdown requests to our request handler. So the sequences have nothing to do with each other. Whatever happens in this sequence does not affect the main sequence until we reach the last step where we set the sequence step to 0. And whatever happens in this main sequence here does not affect the filtration shutdown sequence unless we send a normal or fault shutdown request. However, the requests and everything that's happening at the filtration request handler, they do affect the assets. So the asset doesn't necessarily know it's being shut down because something's happening, or it's being asked to open because something's happening. All it knows is that the command is either there or not there. And we get the free rein to modify how this works, however we need it to. And following this principle, that means that we can add in multiple different types of shutdown sequences. We can offer, cancelable ones. We can offer ones with dialogues on SCADA for timeout periods where operators can decide what to do and things like that, all without having to upset our main sequence. And thinking like that and playing with that, understanding how that works, gives you a completely different range of ability when it comes to writing sequences and how you handle failures. Like always, if you have any questions about this, I appreciate that this isn't a sort of in-depth example about this, but if you have any questions about it, drop me a message either in the comments below or on LinkedIn or Discord if you're on Discord, part of the Do and Grow scheme, and I will do my best to answer your questions.